Right, so for this practice problem, we're going to do 4 things. We're going to determine the order of each reactant, write the rate law, the overall reaction order, and then calculate K. So here we have X plus Y yields Z, and we go ahead and write the generic equation. Rate is equal to baby K times X to M, Y to N. Okay, and our job is to solve for M and N using this data up here. So I'm going to approach this using the table logic way. I'm going to find 2 experiments in which one reactant is remaining the same, but the other one is changing. And I notice here that number 2 and number 3, X is being held the same, but Y is changing. So I ignore that right now. Our concentration of X has no effect on our rate, so the change in rate is all due to the fact that we're changing Y. So I see here that Y is going from 0.2 to 0.4, that's times 2, it's being doubled. And then what happens to our rates? They're going from 1.4 times 10 to the negative 3 to 2.8 times 10 to the negative 3. And a word about some mental math. If the times 10 part, the scientific notation part, is the same, just ignore them. And so really you're just comparing 1.4 to 2.8, and that is times 2. Or you can even think of it as 14 to 28. That's times 2. So our concentration of Y is being doubled. So concentration of Y is doubled. Concentration of X is constant. Rate doubled. So if Y is doubled and the rate is doubled, they're doing the same thing. So therefore, this is first order with respect to Y. So now I know that N in my rate law is 1. So here is the answer for Y. And we're going to repeat that for X. So find 2 experiments in which X is changing, but Y is being held constant. So look for 2 experiments in which Y is being held constant. None. There's no 2 experiments in which Y is remaining the same. So I can't go about this using the table logic way, and I have to approach this using the math way. So this is why it's good to know both methods, because sometimes you won't be able to use table logic every single time. So let's pick 2 experiments in which X is changing, so that we can see how the effect of X is going to affect your rate. So I'm just going to pick the first 2, experiment number 1 and experiment number 2. But I noticed that experiment number 1, that says 10 to the negative 4. This is a smaller value than experiment number 2. So I'm going to solve using experiment 2 over experiment number 1. So that looks like this. The rate for experiment number 2 is 1.4 times 10 to the negative 3. I don't know K, but I do know X is 0.40 raised to the power of M, and Y is 0.20. And I do now know that Y is to the first power. That's what we just solved for above. Divide all of that by experiment number 1, 7 times 10 to the negative 4 is equal to K, 0.20 to the M, and 0.10 to the first. And we're going to simplify. 1.4 times 10 to the negative 3 over 7 times 10 to the negative 4, that's 2. K's cancel. This is going to be 2 raised to M times 0.2 over 0.1, that gives me 2. Okay, we're going to solve for M. I'm going to divide both sides by 2, so those 2's cancel, so I get 1 is equal to 2 to the power of M. So I asked myself, okay, 2 to what power is going to give me an answer of 1? Anything to the 0th power will be 1. Okay, so 2 to the 0th power is going to be 1. So this is 0th order with respect to x. So anything raised to the 0th power will yield an answer of 1. Okay, so I'm done with part A. Part B, they would like for me to write the rate expression or the rate law, and that is simply plugging in the exponents that we just solved for. Concentration of x raised to the 0th power, concentration of y raised to the 1st power. Now typically we don't want to leave it like this because I know anything to the 0th power is 1, so I'm going to rewrite this as rate is equal to baby k times y raised to the 1st power. And typically we don't write the 1, so it's just k times the concentration of y, and this is your answer for part B. Now for part C, what is the overall order of reaction? The overall order is the sum of all the exponents. So this one is just going to be first order overall. So in part D, they're asking me to solve for K, the rate constant. I know that this is our rate law. I pick any of the experiments from the data table and I plug in the values given to me and I solve for K. So I'm just going to pick experiment number 1. It doesn't matter which one that you pick. We should end up with the same answer because K is a constant and it should be the same in all experiments. So the rate is 7.0 times 10 to the negative 4 molarity over seconds. That's equal to K times the concentration of Y of 0.10 molar, and it is raised to the 1st power. So solving for K, I'm going to divide both sides by 0.10. I should be able to do a bit of mental math. So if I'm dividing by 0.10 on both sides, what should I expect to happen to my exponent here? So if I divide by 0.10, that's really saying divide by 1/10, which means that your number is going to get slightly larger by a power of 10. So it becomes 7.0 times 10 to the negative 3rd. And then the units for K, remember our shortcut. It is 1 over molarity raised to the power of overall minus 1 times your unit for time. So 7.0 times 10 to the negative 3, 1 over. Our overall order is 1. That'll be 1 minus 1, and then times seconds. So this becomes 1 over molarity to the 0th times seconds. And we know that anything raised to the 0th power is 1, so this simply becomes 1 over seconds. And there is your answer for your rate constant. 7.0 times 10 to the negative 3rd, 1 over seconds.